quickly share my screen. I hope you guys can see my screen now. Can you guys see my screen?
Yes.
It's still loading, I think. Okay, so let's start. So today's session is all about automate the development life cycle with CumulusCI, and we're so happy like David Reed is giving his time and going us through the knowledge how we can do that. So without further delay, I'll go to the next slide, which is our sponsor. We are thankful about our two sponsors, Appirio and Cloud Vandana. And quick introduction of myself. My name is Sudipta Dev, and I'm a technical architect working for Appirio. I'm also Lightning Champion, and this is my blog and few more details. But I don't want to spend much time about myself, and I just want to hand over to David. So I'll stop sharing, and David, you can start sharing now.
All right. Thank you very much, Sudipta. Thank you for, excuse me, thank you for having me. This is my first time in Canada, virtually or otherwise. And I'm grateful to be with you to talk about automation today, which is a topic near and dear to my heart.
So much.
Now, let me just very briefly introduce myself. My name is David Reed. I'm a senior member of technical staff in the release engineering team at salesforce.org. We are responsible for building the products that I'm going to talk to you about today, and we're also responsible for implementing the continuous integration, release architecture, all the surrounding DevOps material for the products that are brought out by Salesforce.org, including things you might be familiar with, like the Nonprofit Success Pack, EDA, Volunteers for Salesforce, Foundation Connect, and a variety of others. I have 9 Salesforce certifications under my belt. I'm a moderator on Salesforce Stack Exchange, and I've been interested in DevOps for a long time, since I really started working on the Salesforce platform, and I'm really grateful that I get to spend my days now working on tools that make DevOps possible and hopefully make it easy and affect teams that are working on the Salesforce platform to build great software. I have to show you the forward-looking statement slide real quick. Please do remember to make your purchasing decisions based on functionality that is currently available. I am going to show you a couple of things that are not yet released today. So again, make your purchasing decisions based on what is currently generally available. What we're going to cover today, and I'm going to take about 50 minutes or so for this talk, and then I'm happy to discuss and have some questions and discussion at the end. What we're going to get through is talk about the trail to production, the process by which work that you do on the Salesforce platform gets to production, however you define production. We'll talk about what I call the org problem, which is a key problem that folks who are working to implement DevOps on the Salesforce platform face. We'll go through Salesforce.org's solution to the org problem, which we call portable automation. That's the conceptual framework that I'll introduce, and we'll walk through 4 different products that we use to implement portable automation: CumulusCI, MetaHo, MetaCI, and MetaDeploy. And I'll do a couple of live demos along the way. I've said the word product a couple of times already, so I want to start by taking cost off the table. This is not a sales pitch. We are a team that builds open source tooling at salesforce.org. The 4 products that I'm going to show you, CumulusCI, MetaCI, MetaHo, and MetaDeploy, are 100% free and open source. If you choose to adopt this tooling, you can use it at any volume within your organization at no cost. You do still have to pay for any Salesforce licenses that you use, of course, and if you're working with a continuous integration provider like Heroku, Circle, or Jenkins, you'll still have to pay them, but you're not going to pay a penny for the software that I'm going to show you as such. That's something I think is really exciting. I care very deeply about the open source community on the Salesforce platform, and one of the things that I value most about getting to work on this tooling is that it helps to facilitate the creation of open source solutions that can be used by Salesforce customers everywhere, including the nonprofit ecosystem. So let's start by setting the scene. Let's talk about the trail to production and the life cycle of your application. This is how I want to map out the trail to production. I'm going to use 5 sort of schematic stages for how work that you do on the platform moves from its genesis to production, whatever production looks like for you. There's going to be some variance of this trail depending on what your business is and your relationship to Salesforce. So if you're an ISV, for example, production might be your packaging work as you're building a managed package. If you're a Salesforce end customer, production is just your Salesforce instance. You're working from a sandbox or a developer edition or a scratch org, and you're working to move those customizations into your real production org for your business users to make use of. If you're a consultancy, your pathway to production might look a bit like a hybrid of those two. You might be building managed packages that you sell or deliver to your customers. You might also be working to create customizations for individual clients that will go through a number of pre-prod stages and ultimately end up in that client's production org. But regardless of which form of the trail you happen to be walking down, I think you're going to have something that looks rather like this, even if the details are a little bit different. We start out on the left with everything that we build. We're doing development, hands-on on the platform, creating features. That's your developers, your admins, your app builders on your team who are sitting down to do actual work in a Salesforce org. I'm omitting design, by the way. We're focusing really on the trail of the metadata that you're creating here. So somewhere on the left, you've got product managers working and your support staff working and bringing back customer requests and creating these designs. They come in here on the left and they start becoming real. Developers and admins get hands-on. As those features move forward, they'll encounter a number of tests and other phases as they're integrated into your application. And the first of those is a feature test. Let's say you're adding a new feature to your application. Before you move forward with bringing it to production, you're going to test that feature by itself in some way. It's been built in a Salesforce environment, and you hand that Salesforce environment over from your developers or admins to folks who are going to do hands-on testing with that feature. Hopefully everything looks great and the feature gets to move forward. If not, you sort of cycle back to the beginning, devs and admins get hands-on again, and you rinse and repeat until you're satisfied with the quality of your work. Once your feature passes, there's a merge going on of some sort. Now, you might already be working in continuous integration and version control, and you'd be doing an actual git merge at this point. If you're not in that world yet, you might be doing a merge in the sense that you're copying components via a change set or Salesforce DX or Ant or some other mechanism from a sandbox into an integration org, a staging org that you have as part of your pathway to production. But what's happening semantically is that you're bringing those customizations into the main line of your application and getting ready to move them towards production. Once that merge takes place, you'll have some additional phases of testing, perhaps more than one. An integration test, a UAT test, a performance or a load test, a business acceptance test. It takes many forms, but they play the same role in this path to production. You've got a new version of your application in some Salesforce org, and you're testing it out as a whole before moving it into the actual production environment. And last of all, the final deployment. Whatever your production looks like, you're moving your new work into that environment. You're making it available to your customers, whatever customer means in the context of your business. And what I've also mapped out here is all of the different roles that are involved in these stages. So over on the left, we've got our admins and developers. We bring in new roles. We bring in testers. We bring in end users. We bring in demo engineers. We bring in support, business users. There could be others depending on what the shape of your trail looks like. And underlying all of these stages, I'm depicting one more role, the CI system. Maybe you're already using CI, maybe you're just interested in it. But regardless, it's going to play a role in every stage along your trail to production. And here's the key question that I want to pose to illuminate what we're going to call the org problem. And that question is, where are these participants actually doing their work? All these many people in different roles that are working to bring applications out to production in Salesforce. Well, it works a little bit differently depending on what role you are, but there's a lot of commonality here. If you're a CI system, if you're a server somewhere that's running tests for you, you've got to create a Salesforce org. You've got to configure the org to meet the application's needs, do a deployment, run tests, and report results. Well, what if you're a human tester in this feature test stage here on the left? You have to do some things that actually look pretty similar. Build an org, configure the org, deploy that feature, run some tests, report back your results. And the same applies all along the way. Admins and developers, they need to do these kinds of steps too. So do folks who are working closer to production. So do potentially your customer support staff, your IT staff. They need Salesforce environments to do their work in. And one of the key problems, let's just highlight this commonality here. One of the key problems about this is that these steps are really hard, or they're expensive, or they're just incredibly complex. So organizations end up opting for simpler, cheaper solutions like using shared environments and using persistent orgs for CI. But those solutions don't really work that well, right? People get caught on shared infrastructure, they overrate each other's work, state starts to drift, so your test results are no longer reliable, and it's hard to track changes. This is what I'm calling the org problem. All these roles and all these systems that are involved in your pathway to production need a Salesforce org to work in, and it's hard to build those orgs. Traditional tools that you use to build orgs only do metadata setup. They don't do other things. They don't do configuration. They don't do data seeding. They don't do dependency management. If you need multiple org shapes, different kinds of orgs, different configurations for folks like a developer on one hand and a tester on the other, that doubles your complexity. Automation that you build in the context of a CI system is usually not portable. It's only used in CI. It's not something that your users can apply to their own problems to build their environments. And it's really hard to deal with persistent orgs. As anybody who's dealt with shared developer editions or development sandboxes can tell you, it's really hard to synchronize those environments with source control. The change management's not very good, and users constantly conflict with one another. That leads to lots of downsides. Team's velocity gets capped because the infrastructure is not very good. Test results aren't reliable, so you lose confidence. It's hard to implement best practices like source control and Salesforce DX. And a lot of the alternatives that you see to solve this problem are limited, or they're very expensive, and they require specialization on your teams. So with that as background, I want to introduce you to our solution to the org problem. And the conceptual framework behind this is what we call portable automation. Automation that we make available to everyone for every role on the trail, both CI systems and human users who need Salesforce orgs to do their work. The basic framework of portable automation has 3 components to it. And if you've worked with Salesforce DX before, this will look pretty similar to you. That's because we build on top of Salesforce DX. We are an automation engine or an orchestration engine on top of the Salesforce DX ecosystem. So we start with version control as the source of truth. If your metadata is not in source control, it's not real. That's the one shared location for your team to collaborate. We use Salesforce DX Scratchworks as the location of all of our work. They're clean environments, they're repeatable, they're reliable, and they're disposable. You throw them away when you're finished with them. And lastly, we use CumulusCI as the automation engine to make all of this work. CumulusCI builds those Scratchworks for you, and it helps you run the whole process. What makes the automation portable, and we'll continue to delve into this, is that it applies in every context equally. The same automation that we use to build Scratchworks in MetaCI, which is our continuous integration server, is also used by developers through the CCI command line tool. It's also used by admins through MetaCo, which is our web UI for bringing admins into the world of continuous integration. And that is a forthcoming product that I'll demo for you today. And it's also used in MetaDeploy, which is our customer-facing installation solution to deliver your products into the customer's Salesforce work. Same automation in every context. Variation to cope for different needs, but underlying it the same engine and the same metadata. So let's talk a little bit about what CumulusCI actually does. What's the content of portable automation that's actually providing you with help and support along the way? First and perhaps foremost, CumulusCI builds orgs for you, Salesforce DX Scratchworks, based on repeatable recipes. If you've tried to take a product that you're building in a sandbox and convert it to a Scratchwork, I would be willing to bet that you've encountered a lot of challenges around doing things like dependency management, configuring the org to match the expected settings, setting up your org-wide defaults, doing data seeding, all these other little things that are outside the metadata of your application, but that your application needs. CumulusCI does all of that for you. So when you build a Scratchwork with CumulusCI, you get an org that's already set up for your application according to whatever needs you've defined for that process. And there can be many recipes involved in your CumulusCI too. The needs of a developer, as I touched on earlier, might be very different from the needs of a tester. And the automation that you build for those roles can reflect that. CumulusCI also provides each of those roles tools to use in the orgs that have been created for them. That can mean running tests, where we're talking about Apex tests, Jest tests for Lightning Web Components, Robot Framework browser automation or API automation tests, what have you. CumulusCI helps you develop and deploy code and metadata. It has the same types of support that Salesforce DX does. It adds a little bit of tooling on top of Salesforce DX to help you manage that metadata more effectively, but you're still working in that Scratchwork-based development lifecycle. And it also helps you load, modify, and capture data sets. So you can persist data as part of your application, and you can deploy it into each org that you work on. So you've always got a nice, clean, usable data set to interact with as you work on your organization. And thirdly, CumulusCI provides tools for orchestrating the whole development process. This is where that role of the CI system comes in. CumulusCI is an engine for running continuous integration builds. It executes those tests locally for developers, but it also executes them on the server so that you get that result back in GitHub to show you that your work is effective, that it's ready for integration into your application. It helps you automate branch merges. And if you're building a managed package, if you're an ISV or consultancy, it'll help you upload and test beta packages automatically, and it'll help you upload and test managed release versions of your package as soon as you're ready to do so. And one thing I'll note here as well is that we try to keep the entry easy into the CumulusCI and portable automation ecosystem. If you have a continuous integration server that you want to use CCI in, that's great. If you don't, that's also fine. You can actually run and orchestrate the entire development process from your local machine because this automation is portable and it does not care who its consumer is. It'll work just fine for you in the same way that it would work on CircleCI, on MetaCI, on GitHub Actions, or anywhere else. So the way we build automation in CumulusCI is by composing building blocks called flows and tasks. Tasks are just elements of work. They do something in a Salesforce org, like make an API call, deploy metadata. We'll go through a few here. Install managed packages, resolve dependencies for you, run unit tests, run browser automation. We'll come back to browser automation in a minute. Seed orgs with data, run anonymous Apex, capture down changes, release versions. There's lots of tasks that come in the standard library right out of the box. You put these units together, these units of work, of tasks, into flows, and we ship you a lot of flows out of the box as well for each of those roles along the trail to production, and you customize them for the needs of your product. And what you end up with is a very simple definition of automation in a text language called YAML. It looks rather like this, that does some very sophisticated work for you each time you want to build an org. This is real automation that I'm showing you right here. This is from the CumulusCI YAML file for the Nonprofit Success Pack, which is an open source product. And this is a flow that I built to create an org that's tailored for the needs of learners who are working through a specific Trailhead badge. You can see I'm composing a series of steps, 5 steps shown here, that are tasks. All of these are tasks that we ship out of the box in CumulusCI to resolve dependencies, deploy metadata, create a Salesforce record type, install a managed package, and then execute another flow that we've defined that does special configuration just for a Trailhead playground. So again, what we're doing when we build portable automation is we're plugging together these composable units that do work or that do a series of items of work in a sequence that yields some clear result that's oriented towards a task you need to perform or a specific workflow that you're participating in. Part of what's important about this way of defining automation is that CumulusCI.YAML lives in the repository alongside your code. It's a versioned part of your application, and everyone can collaborate on that automation on an equal footing. All right, so I've thrown a lot of information at you in a relatively short amount of time, and one of the things that I'd like to make sure to do before we wrap up today is make that information concrete with a hands-on demonstration. And what I would like to do today is give you a quick demo of how to start a CumulusCI project and turn a bunch of uncoordinated metadata into a managed package in a very short amount of time. Let me show you where I'm working right now. I am in a folder called Food Bank DSDG Demo. It contains a Salesforce DX project, and there's not very much to it. This just has a couple of page layouts and a couple of objects. This is an example application that we use a lot that demonstrates a very simple Salesforce implementation for a food bank that wants to use the Nonprofit Success Pack. We're starting with just some custom objects though. And this is just an ordinary Salesforce DX project. But what I'm going to do is I'm going to use CumulusCI to turn this into a managed package. I'll walk you through how the automation works, and we'll release a managed package version in the next 10 minutes or so. So first thing I'm going to do, I've got CumulusCI installed, and I'm going to do CCI project init inside my Salesforce DX project. And it's going to ask me some simple questions about what I want to do. I'm building a managed package. And I'm going to use a namespace that I've already set up for this project. The one thing I'm cheating on here a little bit in showing you this flow is that I've already got a packaging org set up, but otherwise this is what you'd actually do if you wanted to take some existing Salesforce DX metadata and turn it into a CumulusCI project that builds a managed package. I'm just answering some boilerplate questions here that helps CumulusCI understand how to set up my project and communicate with GitHub, which is where my project is hosted. You can see my project is now ready for use, and if I look at my directory here, I've got some more things that have been created automatically for me by CumulusCI. One of them is this cumulusci.yaml file that defines my automation. I can take a quick peek at that. You can see that the CumulusCI YAML starts out with some really simple metadata. If you were watching closely while I answered that questionnaire, you'll see that my answers are represented here. So this is defining part of the skeleton of my project's automation, how I tag my releases, how I tag my beta versions, what API version I want to use, what my namespace is, and so on. And you can also see that we've got some automation out of the box here. We've actually defined two custom tasks for this project as part of the initialization process. What these two tests are doing, these are browser automation tests that we give you for free in each project. They go into an org and create a contact. So it's a really simple way for you to check that your project hasn't accidentally broken the standard object. And it's a skeleton that you can build out to create really sophisticated robot framework browser tests that script your application in a web browser the way a user would, clicking through pages, and make sure that your application operates the way you expect it to. Let's close out of here for now. Because what I'd like to do next is go ahead and build a Scratch org for this application, take a quick look at it, and then build us a managed package release. As I mentioned earlier, CumulusCI comes with a lot of flows and tasks out of the box, and I can get a look at that in the context of my project by doing CCI task list. That'll tell me all the things that I can do. You can see there's a number of different groups of operations and automations that we provide for free. So you can do things like waiting for batch apex to finish. You can mutate metadata that's in the org programmatically rather than creating your own metadata. You can build managed packages. You can pull down metadata with retrieve changes, just like you can in Salesforce DX, because again, we're building on top of Salesforce DX. You can interact with the GitHub API to do interesting things like build automation on your pull requests and automatically accumulate release notes for each new version of your application. That's something we use extensively. You can run your browser automation tests. And one of the things that I like most is you can interact with data sets. Touched on that earlier, and we can look at that a little bit more here. We can define a data set that works with our application and make that part of our product automation to expose it to everybody who's part of this application's journey. Let's start, though, with a flow. And again, just like tasks, you can get a list with CCI flow list to see what's available to you, what you can do. And we're going to start with the flow called dev org. This is a flow that creates a Scratch org. It's designed for building metadata. And I'll just do flow run dev org. I'm going to build an org called dev. So CumulusCI is going to tell us quickly here what it's actually doing. It starts by calling out to Salesforce DX to create a Scratch org. And in a moment when that completes, what we'll see is a schematic of the automation that's about to run to configure that development Scratch org to the needs and specifications that my project here has established. One other thing that I'll highlight in the list of flows here as CCI is working on this is that there's flows that come out of the box predefined for a bunch of different roles that we touched on earlier on the trail to production. I'm using a dev org because I'm going to take the persona of a developer here. If I were a tester, I might be using QA org to build a testing-oriented Scratch org, or a regression org to check out my latest release. Or I might be using a flow like install beta to install a beta version of my package and evaluate it in the context of a Scratch org. But here's what's happening. CumulusCI has shown us a quick summary here. It's running a dependency flow to make sure that any managed package that I'm dependent on is already installed in my org when I start out. If I needed NPSP, for example, that would be installed for me. It takes about 15 minutes, so I'm not going to do it here. It's deploying my application, and it's running a couple of post-deployment configuration steps to, for example, update my admin profile so that I automatically have field-level security to everything that's part of my app in the context of this Scratch org. That's what's executing right now. You can also see here that all of my Salesforce DX metadata has been uploaded. I've got my fields, objects, and my layouts in place. Sometimes the metadata API takes an extra minute or two on deployments, but here we go. I should mention too that
there's a few questions in the chat.
I cannot see the chat. Would someone like to take a moment to offer one or two up, and we can talk through them while this is working? So, Dipta, do you want to grab a question?
Yes. So the first question came from Jaswinder, and he was asking, like, if all of these different products are using the similar CLI commands, then why not use all those in one tool? Why create different tool for each role?
We do use the same tool for each role, but we run different flows for each role. Let me give you an example in just a second here. I just want to crack open this org and let you all see that we've created a Salesforce DX scratch org that's configured according to what we expected. To try to get back to that question though, CumulusCI is the same tool that we'll use for every single role. So when we're running builds of CI at salesforce.org, and we've run something north of 200,000 continuous integration builds in the last couple of years on CumulusCI, we're running that same CCI command that I just executed right now.
Mm-hmm.
The same tool is being used by, go ahead.
Yeah, sorry. When I said tool, sorry, I didn't mean the CCI. I meant those Meta CI or those others. Why create different UIs for each one? Why not just have everything in one tool?
Good question. Good question. Sorry, I misunderstood. They do somewhat different things. I'm going to dig into that in just a second here. Here's our delivery object. So yeah, again, we've got a scratch org here. If I had customized my dev org flow, which I haven't done for this project yet, I'd have customization in here. Let's put in a flows section to do something like this. That's all I would have to do. This is quite real. This is all I'd have to do to get a data set loaded up into this org every time I create a developer scratch org. So I'd have a real view of what a user might be experiencing when they work with my application. And my experience of the app can be that much richer. My experience testing it can be that much more effective because I've added a couple of lines of YAML here that make sure that I've got data present that I've previously captured. And
where is the data sets defined?
The data sets are defined in the repository alongside the application. And you can see when I created the skeleton, I got a datasets folder here for free. And inside that folder is a mapping definition. This defines what data you're interested in your application. We give you an example that pulls some standard fields out of accounts and contacts and persists them locally, and then can load them back up into any other org that you build. You, as part of defining your automation, can iterate on this mapping or create new mappings with the tools that we provide to generate them automatically that define the schema of your application, including whatever standard objects you use, all the custom objects that are part of your package, any custom objects you rely on from other managed packages that you utilize. And that will allow you to capture down a complete data set from an org that you've built out and redeploy that data set into any org that you create. One of the things I'm going to point you to at the end of this discussion as well is that we have recently created a trailhead of build applications with CumulusCI that walks you through the whole process of setting up and building a project in CCI. And the fourth module, data management with CumulusCI, walks you through actually creating a data set in an org and persisting it as part of your product automation. Does that answer your question?
So the data sets, you don't actually define them in that YAML. You create them in a dev org and then you load them down into your project?
That's right. You create the data set in an org and then you persist it locally, and we store it in a SQL database inside your repository. And then the automation that you define in your YAML file tells CumulusCI how and when you'd like that data to be loaded. I should mention as well that we've got one other product that I'm not going to talk about today in depth, that does let you write YAML descriptions of a data set that you'd like to be generated for you, and then do an execution of that and load it up into an org. Go ahead.
So then if you, say, added a new custom field to accounts, you just have to go into the YAML, add that new field, and by the looks of it, it's literally just the name of the field, colon, the name of the field?
That's exactly correct. And then that field will be captured for you.
And then for you to persist any data, you would have to then go into your test org or whatever development org you're pulling the data from, add that field, and then add the data to the field to persist it.
That's correct. That's exactly the workflow that our development teams use. They've pioneered a process that they call storytelling data, where they build very sophisticated customer-like data sets to help them understand and experience user workflows. And what they do to maintain that data set as they continue to develop the application is they'll build up build an org, and all their orgs include the storytelling data. That's part of their process. They'll go in, they'll build a feature. As they're building that feature, they'll populate data. They'll mutate their storytelling data to match the new feature they're developing. And then they'll capture back down both the feature development that they've worked on and the data that goes with it, and make that a permanent part of their application.
So you would just, in your Git repository, you would actually have that like a branch until it goes into the main?
That's correct.
And the SQL data would be, of course, migrated over when you merge the branch.
That's right. It's part of your version control alongside everything else that's part of your application. So I want to just go back to the trail to production very briefly here to highlight that many of the things that we've seen so far, and some more that we haven't explored so far, map back to the different roles and stages on the trail to production. We used dev.org to build a development org. Talked a little bit about QA org. That's another flow that corresponds to a different role. We've got other flows that we make available out of the box that support different roles, like the CI flows to be run in your continuous integration system. And finally, the most important part, the flows that you run to deploy your work to production, whatever production looks like for you. Just to bring it back to the org problem as well, the things that you get when you solve the org problem, whether you use CumulusCI in combination with other tools or some other solution, is your teams can work faster because they're not held back by infrastructure problems. You typically find more confidence, especially among your QA teams, in the results. You can be more confident as a product team that you're delivering really great software that does exactly what you think it does and doesn't have any faults, because you're never facing skews from stale state in your shared orgs or conflicts between different teams. The modern best practices that we talked about earlier, like source control and Salesforce DX, it's not just that you have to do those things to get this portable automation. It's that portable automation actually makes your use of those underlying technologies more effective and more valuable to you. So that ideally, what we see here is a positive feedback cycle, a virtuous cycle between adoption of these different technologies. And every user who's part of your organization gets access to a holistic environment that encourages them to collaborate and share work across functional boundaries. Now, one of the questions I heard articulated earlier was, what about the rest of this suite that I mentioned? And I want to turn to the rest of the suite now, and talk about how portable automation applies in all these other contexts for folks who are not using the command line every day, and what's important about these other applications that we've built, how they're distinct from CumulusCI. I'm going to start with Metecho, which is our portable automation for admins product, it is forthcoming. It's not public just yet, but it is coming in the near future, we hope. And it's something I'm really, really excited about, and I'm happy that I get to share it with you today. I'm actually going to skip over my slides here because I can give you a live demo, just a real quick one, of the application. What I'm so excited about with Metecho is that this is a web application. It runs CumulusCI under the hood. CumulusCI is the automation engine, and that's true for all of these other products that we've created. But it presents this UI that is friendly to everyone on your team, even if they have never seen Git or command line before. And it lets them fully participate in a source control-based branching development lifecycle that uses CI everywhere. And I want to show you real quickly how that works. I've created a project here in a repository called CCI Food Bank called Kitchener Development. Projects are how we organize work in Metaho for all the people who are collaborating here. And projects are broken out into tasks. I've added a task here for us to take this food bank application and add validation rules to it. I have assigned myself here as the developer and the tester of this particular feature. So if we look back at the trail of production, we're in the far left here. We're in admin. We're iterating on a feature development piece here. As the developer, I can click a button here to create a developer org for this product. That's going to take just a couple of minutes. And it's going to deploy the current version of the app into that org, get it all set up for me. I'm not going to have to type any commands or touch a command line. So that's a nice convenience. We also have that available in our CumulusCI product that I'll show you in a minute. But what's really exciting about Metaho is not just that it builds orgs for you, which we can do with a number of different products, but how it helps you extract the work that you've done from those orgs and make it available to the rest of your team for testing and evaluation and merging in a way that's really ergonomic, that doesn't require you to even know that you're utilizing a continuous integration system while still getting all the benefits of it. So I've got my org built. Let me dive in here. I'm actually going to create a piece of metadata here. I'm just going to build a validation rule that'll take a second or two so we can look at how we extract that metadata and get it pushed into Git without ever actually knowing that we're using Git.
And the connectivity between Git and your tool, I'm assuming that has to be set up. But once it's set up, then anybody using the tool basically automatically goes into the branching systems?
That is correct. The setup is done once per repository. So whoever's administering your project or building your DevOps infrastructure would do that one-time setup to make the repository available to Metaho, and then the rest of your team would not need to do any of that setup later. Oops, I wanted to be in validation rules here. Let's just create a validation rule on account. And I'm just going to say that we can't insert an account whose name is test, which seems like a reasonable exclusion to me. We don't want any tests in production. I'll save that. So if you're working in Salesforce DX, you probably anticipate that what's happened here is Salesforce DX is tracking the change that I've made in this Scratch org, and I'm going to do some kind of Salesforce DX retrieve to get it integrated into my work. That's exactly correct. And that's what Metaho is doing under the hood here. I'll do a check for changes in the org that Metaho built for me. It's observed there are changes. It's asking me where I want to put them. One of the things we support across all of our portable automation ecosystem is the concept of configuration directories. That's what you see here. So you have the freedom to store metadata that's not really part of your application, but that you use operationally to support it. Like here, I might want to store this validation rule and make it available only for QA orgs, QA being called out here. In this case, I'd like to make it part of my package itself. So I'm going to choose my primary Force app directory. I get to browse through all the changes that Salesforce DX has tracked in this Scratch org and decide which ones I want to capture as part of this task. And a commit is going to be created for me automatically on a feature branch that's built by Metaho behind the scenes that I can then make available to the rest of my team, like the tester that I've assigned here, for evaluation and quality assurance. The tester, when they come into this task and want to get their hands on the work that I've done, they don't have to share an environment with me. They're not going to get into my dev org. They're going to build their own test org. So I could click create org now and go ahead and do that. And if we had defined any special setup that's for the testing role, that's for QA, they get an org that meets those expectations rather than an org that's built for me and my developer expectations. But it would still include all the work that I've done so they can take a look at it. If I duck into Git here, into GitHub by clicking View Changes, you can see that what's been done under the hood is we have created two branches, a branch called Feature/Kitchener Development. That's the project that I showed you at the beginning, and a sub branch for Add Data Validation Rules, which is the task I'm working on right now. We'll not go ahead and create the pull request just yet. We'll let the tester do their work, but once the tester evaluates the work that I've done here, you'll see the progress bar continue, just like working an opportunity in Salesforce, and we will automatically create a, I could go ahead and submit this task. The team that's building this application is constantly iterating on it, and I keep being surprised by the new and really interesting things that they've brought out and the new features that they're adding. I'm really excited about this. A pull request will ultimately be created for me when we're ready to merge this in. And I, again, as the admin, I don't have to touch Git, but I'm participating fully in this ecosystem. I've committed my work to version control. It's going to be checked by my CI system, just like any other code that a developer has written. And I, as an admin, get to be a full and equal participant in that. So that's what I think is so exciting about Metaco, and I think it will be a real game changer in allowing admins to be full participants in the CI/CD Salesforce DX ecosystem without forcing them to learn a large cadre of new things like command line access or mess around with the command palette in Visual Studio Code. So that's something I think is really, really exciting, and I'm eager to see folks start adopting it. Let me quickly run through. I'd like to save some time for QA, but Q&A, but let me quickly run through the other two applications that are part of this suite. The first is CumulusCI. We touched on this a couple of times. CumulusCI is our in-house continuous integration server, which runs on Heroku and is specifically designed for running CI builds on Salesforce projects and helping to orchestrate the development lifecycle of a Salesforce project. I mentioned earlier that CumulusCI comes out of the box with automation to help you do that project management, to help you automate merges into feature branches, for example, and make sure that beta managed packages get uploaded at the right points in time along your pathway to production. CumulusCI makes it really easy to hook into those CumulusCI flows because it's running CumulusCI for you on Heroku, and it's giving you all the other standard expect in a CI system. It reports build statuses back to GitHub, so you get your green checks when you're ready to move forward, but it's doing all of this in a way that is very much aware of how CumulusCI works and how Salesforce works in a CI and a DevOps context. I'll touch on this again later, but just to clarify, CumulusCI is not something that you're required to use with CumulusCI. It helps. It makes it easy to define plans that run CumulusCI automation, but you can take CumulusCI and you can run it locally, or you can run it in any CI system that you prefer to utilize, including on-premises systems, if that's something that's important to your company. We ourselves use CumulusCI in some contexts in CircleCI, so you can see that it's a first-class citizen to operate in that way. And we also support the open source commons program at salesforce.org that helps use CumulusCI in the context of community open source projects, which are a really cool initiative. The last of the four products I want to introduce you to is Deploy, which is our tool for using portable automation to achieve customer delivery of a product. Deploy, if you've ever worked with our nonprofit products before, you've probably used Deploy. It's located at install.salesforce.org. That's our instance of Deploy. And its purpose is to deliver products like the Nonprofit Success Pack and Volunteers for Salesforce and EDA to our customers by executing portable automation on their orgs. So this is a bring your own org solution. Users log into Deploy with their org where they'd like an application to be installed. We show them a nice visual representation of what our automation has been defined to do and allow them to execute that for themselves in the context of their own org. Again, they don't need to touch CCI or Git. They don't need to know that there's portable automation under the hood, but that's exactly what we're doing. And the same portable automation that we've defined and made available to all of our other roles can help us to deliver a really high quality application to an end user in a way that provides a very good experience. So if you've got a complex application like the Nonprofit Success Pack that has 5 dependencies, for example, 5 managed packages that it requires, and also has a number of other setup steps that users might have to manually execute, you can automate all of that with Deploy and give them a much friendlier experience. We use this for all of our products at salesforce.org, and it's the primary way that we recommend that folks get access to the Nonprofit Success Pack and other tools in their existing Salesforce orgs. So let me close out and open the floor for questions. The thing I really want to leave you with is this idea that CumulusCI and portable automation in general make sharing and collaboration easy, whether you're collaborating across one organization, across multiple organizations in a consortium or in the open source community. between roles and on open source products that are built by the community or built by our Salesforce partners. That's part of our mission and our raison d'etre. Thank you very, very much for coming. Thank you for listening. Thank you for your questions, and I'm happy to talk more.
Thank you, David. Okay, so we have few questions here. I'll go through one by one. So the question that came up here, like, will this task the target source org, like the change set and the ant deployment too?
I'm not sure I quite caught that, but let me try to answer. So you're asking about the difference between, or how there's alignment between.
I think it's asking, like, change set and ant deployment will lock the target and source org. But what about the task that you showed? Is it going to do the same thing, lock the target and source org?
I would say generally yes. Anytime you do a metadata API deployment, there's going to be a lock established on the target org for certain. We don't really have a concept of a source org in CumulusCI because every deployment that you do is from your version control system. That's your source of truth. So we don't move from org to org in the way that a change set does. We move from source control to an org. However, we, like Salesforce DX, like Ant, like most other deployment tools that you'll work with, are a client of the metadata API. And anytime you work with the metadata API, you will see a lock established in the target org during the course of that deployment.
Perfect. Yep, that's what I'm. Okay. So the next question is, like, where can we define the dependencies?
Great question. Let me show. Actually, I have a tab open to show you that. So this is the real CumulusCI YAML for the Nonprofit Success Pack, which is it's a fairly large, complex managed package suite. And right here on line 20 of this CumulusCI YAML is the definition of the dependencies of this product. It's in your CumulusCI YAML, just like any other markup. And what we're saying here is that this particular package, NPSP, is dependent on 4 other managed packages that are stored in GitHub as CumulusCI repositories. That's an option that's available to you. So if I wanted, for example, to declare a dependency in this little project we were working on here, I could do it that way by editing my CumulusCI YAML and adding a dependencies section. And putting in the URL of a GitHub repository that includes this CumulusCI project. That's not my only option, though. If I'm dependent on a product that is not a CumulusCI project, I can also do that by just calling out a dependency on the namespace. For example, if you were working on a project that's dependent on the NGO Connect product suite, you could declare a dependency on a specific managed package namespace and a specific version, and CumulusCI will still automatically manage for you installing that specific package. You get a little bit more functionality if you're working with GitHub repositories because CumulusCI can go look at that repository, understand what the requirements of that product are, and execute them automatically for you. But it's also perfectly capable of just installing managed packages that you specify by namespace and version number.
Okay, good. That's good. Okay, the next question is, like, it's about the data set. Like, in SMP, like, there is a limitation of 200 records that we can load. So is it the same here?
That is a great question. Let me, I will answer that, but also show you an example of a data set here in the context of the Nonprofit Success Pack. We are not bound by those same limitations. The way that Salesforce DX works and handles data is by using SOQL queries and by using the tree API. In CumulusCI, we don't use the tree API, we use the bulk API, and we handle persisting and retrieving object networks for you. So if the data that you're working on involves a lot of complex relationships, contacts to accounts, to opportunities, to opportunity contact roles, to payments, and you have cycles in that reference network, like an account has a reference back to a primary contact or something like that. Those are all things that cannot be handled by Salesforce DX because it doesn't use an API that supports that. CumulusCI does. We can extract all of that data. We can load it all up in a single operation into a new org that preserves all those relationships, and we can do it at scale. One of my colleagues on the release engineering team specializes in performance engineering, and he has done on quite a few data loads into large data volume testing organizations with CumulusCI that scale up to 50 or 60 million records, and that works just fine.
Okay, that's good. That's huge.
Yep. Sorry. Can you give an example of that complex relationship?
And here's an example, by the way. Absolutely. I'll show you one right here. This is the mapping file for the Nonprofit Success Packs data set. And one of the things that you will see is, oh, this data set's actually not capturing that. It should be. One of the features of the data model in the Nonprofit Success Pack is that the account object has a reference to a contact. But contact, of course, has a reference to account through the account ID field. Let me see if I can find a data set that actually preserves that. Well, actually here, what I'll do is I'll just show you what that would look like, since this particular data set is not using that feature. Let's just focus on the account and the contact object, because they have a complex set of connections between them. Account looks up to contact via a lookup field called primary contact. So that's a reference to one of its own contacts. But meanwhile, contact has a relationship to account. It looks up to account through the account ID. And in the context of the Nonprofit Success Pack, it's got a second lookup for a primary affiliation. If you're trying to do a data load on that using a tool like the data loader, it means you have to do a number of different passes, right? If that's something you've ever done by hand. I've certainly done more my share. You'd load up a CSV full of accounts, for example, and then you'd run a query to get the new IDs out of the target org, and then you'd open up your contact CSV, and you'd have to map the IDs for your account ID into the new IDs that you just created. Then you'd upload your contacts. And then if your account's got a reference back down to the contact, you have to do yet more steps to pull those accounts back down and then push them back up with new IDs to populate those references. CumulusCI does all of that for you, and it automates the extra steps that need to be executed. So again, if we're loading accounts first and then contacts, but account has a reference to contact, we just have a little piece of markup here that tells CumulusCI that we want to populate this particular reference after contacts have been loaded so that the IDs are now available. It gets very complicated in some data models. It depends on what your application looks like. But we try to support all those different variations. And one of the tools that we offer to help with that is a task called, Generate Dataset Mapping. Generate Dataset Mapping. And what that task does is you give it an org that you've already created, and it will go inspect the schema in that org, all the objects and interrelationships between them, and create the mapping file for you. So you don't need to go through and build this out yourself, at least not to start. You can start out by running this task, let it give you a skeleton for a mapping that preserves those relationships, and then you can iterate on that mapping as you continue to build out your application and make changes to it as you need to support your schema. Does that answer your question?
It does. Thank you. I wish SFDX CLI had something like this. This is one thing that's blocking our project. So
absolutely, I was about to say that, like, this generate dataset mapping.
Yeah. Well, what
is like game changer.
Yeah.
Thank you. I wrote Generate Dataset Mapping, so I'm delighted to hear that it's got that value for you. And one thing I will mention as well is that we really do try to make sure that our tools are not, there's no lock-in, that there's no all or nothing decisions that you have to make. So if this is something that you're interested in digging into to get your feet wet, you might have to do a little bit of different configuration than we recommend in our docs. But if you want to use just CumulusCI's dataset tools in the context of an existing Salesforce DX project, that should be possible for you as well.
But it needs to be installed there to be able to use it.
That's correct.
Okay.
Speaking of the install and everything, how difficult is it to actually get this all set up? I missed the first 5-10 minutes of the call, so maybe you've already gone over that, but I'm just wondering.
Yeah, I don't think it's hugely difficult to set up. CumulusCI is a Python application, so you do have to have Python in place on whatever system you're working with. But Python, you may know already, it's one of the most common programming languages around. It's available on every operating system there is, and installing it is generally a fairly painless operation. There's a couple of extra steps that users on Windows have to do to make sure that Python's fully configured for their systems. But once that's done, it's done. It's a thing you do once. And then it's just a single command to install CumulusCI.
Yeah, I mean, to get Python, literally you can go to ninite.org and it'll auto-download it for Windows. Works great.
Mm-hmm. And it's something that's also available on any CI system that you can name.
Yeah, I think it pretty much is. So this build applications with CumulusCI, does it walk you through everything? The downloading of the tool, putting it on your local station, going from there?
Mm-hmm. So
Awesome.
we've got 6 modules in this trail here, and we start out with great. We start out with the bare bones of just what it means to use CCI for collaboration. We'll walk you through how to set it up, how to start out a project, how to manage dependencies and data, and wrap up with building something that you could kind of think of as a consulting project where you extend a managed package and build that out for a real production Salesforce work. So give it a try.
Nice.
Hey David, I have one more question here, and this is a very important and very interesting question. Like, can this tool be used for any organization who are not using the Scratch org?
That's a very interesting question. I would say somewhat. There are some portions of CumulusCI that you can use effectively in the context of a sandbox or developer edition based development lifecycle. You will get a lot more value out of CumulusCI if you do move to Scratchworks. And part of the value that CumulusCI offers is helping you make that transition, giving you the right tools to make that transition. If you do need to stay with your traditional persistent org based development lifecycle, you can still use CumulusCI as a build tool. It can do deployments into a persistent org just like any other tool, just like Ant, just like Salesforce DX. It can do data loads and data extractions from a persistent org, so you can get that value out of it. But you will benefit more if you migrate to a source control-based, Scratchwork-based development lifecycle.
Perfect. And one or maybe 2 last questions that I have.
All right. So one thing
sorry, go ahead.
Well, one thing I want to leave everyone with is some resources. We can do some more questions as well, but I do want to make sure that everyone gets access to resources for digging in further if that's something you're interested in doing. I've already highlighted our trail on Trailhead, which we're really excited about. That came out just recently. You can also find our documentation on Read the Docs here, and I'm happy to share this slide out, or all these slides out, so you can get these URLs. We have a group on the Trailblazer community that's just called CumulusCI, where you can come talk with us about what you're doing. And again, just to reemphasize, CumulusCI is an open source project. You can go look at our code, open issues, submit a pull request if you're so inspired. And you can also take a look at many of the existing projects that are open source that use CumulusCI to see how this tool is being applied in the real world with products like NPSP and EDA, but also with our open source commons community partners at SFDO Community, who have created more open source Salesforce projects that use CumulusCI to help nonprofits do exciting things.
One question, for this, is there any part of it, like I know it's open source for some of it, but I noticed you said there's other tools that are coming out. So are all these tools free to use, or there's a cost to them? Is it part of the licensing? Like, how does it work?
All 4 of these tools are 100% free and open source. Nice.
Okay, great, thanks.
Free as in beer and free as in speech, as the open source community likes to articulate it. As I mentioned at the beginning of the call, you still have to pay for your Salesforce licenses, of course, but I think that most users of CumulusCI don't need to pay for additional licenses. The licenses that you'd be using would be the same ones that you allocate to your developers anyway. If you're going to use CumulusCI, you'd be responsible for the charges that you owe Heroku to run that product, but you don't pay for the product itself. And you do always have the freedom to run an on-premise CI server, for example, if that's your preference and if it fits better with your cost structure.
Yeah, that's what I was going to ask. So we have that tool CLI available locally to work with, but if we need a UI tool that can work like Jenkins or the one you showed, then we have to pay wherever we want to host.
Well, you're always going to have to pay your hosting provider. That's right. We
Right.
don't provide hosting. If you want to run our CumulusCI tool, that tool is free, but you'll have to pay your host. Same applies for Jenkins, for example. It's an open source product,
Right.
Jenkins is, but you still have to pay for the hosting.
Right.
Yeah. Okay. And sorry, one last question. I still have to go to the trailhead for CumulusCI. So does it have its own UI, or do we have to use something like CumulusCI?
CumulusCI is a command line tool, and that's what you'll use throughout that trail. So you would be interacting with it in the context of, if I can get my screen to cooperate here, you'd be interacting with it in a terminal similar to this one in Visual Studio Code. And Visual Studio Code's also free and open source, so there's no cost for anything that you need to complete the trail.
Okay, got it. So anything where we can schedule tasks or things like that, that has to be CumulusCI or Jenkins or what have you. Okay.
That's correct, yes.
Okay, thank you.
Although I'll also mention, though, that I have heard of projects that are using CumulusCI where they have a very small team. They maybe have one developer, and that developer runs the whole development lifecycle from their local machine, just executing CumulusCI. So if your scale fits with that, that's also an option for you.
Okay. And can this be installed in Node.js?
It can be installed alongside Node.js. It doesn't. It uses Salesforce DX, which is a Node application. So you'll have to have Node installed, but CumulusCI itself is a Python application and doesn't have any dependencies on Node itself.
Okay, so it has to be installed separately. Okay.
Mm-hmm. It's pretty easy to install in most contexts. Like in a CI server, for example, you just run one command, pip install CumulusCI, and that'll get you ready.
Okay, got it. Yeah, we have a project where I'm wondering if we can install it and use it there. Okay.
Cool. That's exciting.
Good. And the last question that I have, David, the UI thing that you showed me, I forgot the name.
Yes.
When thing is coming for us? When we can use that?
I don't have a release date to share today, but we are very excited about bringing this application out. It's under very active development and starting to get some early exposure at our Salesforce.org community sprints. So I wish I could tell you a day when it will be public, but I do think I can say that it will be in the not too distant future. We're all very excited about making it available for the community.
Okay, that's perfect. We'll look for that. Good. I don't think we have any more questions here.
All right.
With that, we can end the call. But yep, thank you, David, for coming to my community and sharing this knowledge. It's really helpful. And thanks for all for joining this call. I'm going to record this session and I'm going to publish that in YouTube, and you'll probably get an email, if not today, end of the day, but definitely tomorrow.
Wonderful. Thank you very much to everyone for coming to this session, and thank you for your questions. I'm really excited to see the use cases that folks have and the things that you can enable by having this tooling available. Thank you.
Thank you. Thanks, guys. Stay safe. Stay home.
Thanks, everyone. That was great.
Thanks, all.